Okay, take out your books and note down, okay, everything, because I will going to ask numerical from this grouping of resistance. Here we have two types of grouping. One is series and one is parallel, just like we have done for grouping of capacitance, nah? But the formula will be same, but it will be opposite. Like we have uh, capacitance in series and capacitance in parallel, nah? Formula will be same, okay, but opposite. Now capacitance in series will be the formula of capacitance in series and resist resistance in parallel will be same, okay. So here resistance in series, see opposite, okay. Okay, now first, in a circuit, how do we represent resistance? Resistance is represented like this, okay, or R for resistance. In a circuit, we represent resistance with this symbol, and cells this one, no? Or say, I mean capacitance, two vertical lines, nah? Equal vertical lines. This is capacitance and this is resistance. Now let's see what is resistance in series first. So two or more resistance are said to be connected in series if same current pass through each of them when some potential difference is applied across the conductor. Means the two or more, the resistance, in all the resistance the current will be same. Okay, I will take the example of three resistance, R1, R2 and R3. Connect with battery, so current will go, let's say I current. Okay, this current is going through this R1 resistance, nah? Like this it will go, and the same current I is also going in R2 resistance, nah? And the same current I is also going in R3 resistance. So that means they are connected in series, okay. If the same current flows through this resistance, then it is said to be connected in series, okay. Or see, series means one after another, nah? Let's say this is head and this is tail. Okay, color, yes, color. Let's say this yellow represent the head and this blue represent tail. So here also tail, head, head. So series means, see, this head and tail are connected, nah? This one here also head and tail, nah? So that means they are connected seriously, nah? In a series or in a line, nah? That means one R1, R1, R2, R3. So they are in series. So this type of connection is called series connection. Okay, so the resultant of these three resistance, here I am talking only about three resistance. Okay, there may be 4, 2, like this, any number of resistance. So the resultant, what is the total resistance, or the resultant of these three resistance? So R means resultant of all the three resistance will be equal to R1 plus R2 plus R3. Okay, so in place of this R1, R2 and R3, we can directly write one resistance which is equivalent to R1 plus R2 plus R3. Nah? So we will have only R, because this R is R1 plus R2 R plus R3. Instead of writing all the three resistance, we can represent it with just one resistance, and this R is equal to R1 plus R2 plus R3. So in the case of capacitance, that means C equal to C1 plus C2. Nah? This is the capacitance connected in parallel. Nah? But in this case, instead of C, we can write R. Nah? So this is the formula for resistance in series connection. Okay, next is resistance in parallel. So two or more resistors are said to be connected in parallel if potential difference across each of them is equal to the applied potential. Or parallel means all the resistance should be in parallel. Nah? So parallel is this one. So here also I will take three resistance, R1, R2, R3. Okay, so they are connected in parallel. See, the potential across all these individual resistance should be equal. Okay, that means R1, this is R1. Nah? R1, see, they are in the same point. Nah? Okay, that means their potential is same. Okay, in case of resistance in parallel, potential across all the resistance are same. Okay, that means V means potential, right? Potential is same, but current is not same. Okay, not same. So if suppose we apply I current, nah? So it will go here, and here we have three branches. Nah? Three. So this current will divide into three. Nah? Three parts. Let's say I is 30, okay, or 35. Nah? So here 35 ampere. So here at this junction, here we have three root. Now this one and this one and through R1 also. Nah? So this current, nah, it will divide into these three parts. Okay, let's say in first case here 5 ampere flow, 5, the total is how much? 35. Nah? So we have 30 left, right? So let's say here it is 15 ampere is flowing here, 15. So 15 plus 15 is 30, 30 plus 5 is 35. Nah? So the in parallel connection across the resistance, the current is not same. Okay, the current is not same. just remember. So what will be the total resistance, or the resultant of these three resistance will be 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the resultant resistance of these three resistance connected in parallel. Okay, so we have to find R equal to, so if you take LCM of all these three, R1, R2, oh, this is 1 by R, right? R1, R2 and R3. Nah, no need to do all this. From here also you can find. Okay, so this is the formula for resistance in parallel. See, first you have to write like this. Okay, after that you have to find R. Okay, R in upside, nah, not downside. Okay, after putting all the value here, we don't have value, right? We cannot put. So if you have value, then you put the value and then calculate and then find R like this. Don't find R like this. Okay, 1 by R equal to, nah. So you, after putting all the values, you have to bring this R upside, nah.